Hello class, welcome to our lesson today dealing with section 7.2. We're going to start dealing with estimations of the population proportion. Later on in sections 3 and 4 we'll look at population mean. There may be some tables that we're going to want to look at. I'll try to post those as we move through some of these lessons. For now, what you need is your z-score chart. So make sure you have one of those handy as you're looking at some of these scenarios. It'll be more beneficial probably later on, but for now, just make sure you have that ready, and you should be able to use that to help answer some things on today's lesson. Everything with probability, remember, is percentages or decimals. So we're going to use this example here. 70% of 1,501 people have brown hair. The sample statistic is 70% or 0.7. That's also known as the sample proportion. That's denoted by p hat. So p with kind of, it looks like a hat or an arrow on top of it. That's p hat, which is the sample proportion. This is what's known as the best estimate for the population proportion. Another word for that is point estimate. So if you ever see anything that says what's the best estimate or what's the point estimate for a proportion question, it's whatever the sample proportion is, and in this case it's the 70% or 0.7. I would say in many cases you want the decimal here because you're going to be using those in different formulas. So you want to make sure that you have it as a decimal, not as a percentage for those formulas. The other thing that we're going to be adding in here in Chapter 7 is what's known as a confidence interval. P hat is the best estimate for what's there, but we don't know if it's a good estimate or if it's off or how close to what the population proportion really is. And so what we do is we develop an interval known as a confidence interval. You may also see it as interval estimate, but typically confidence interval, which kind of gives you a range of numbers that you'd say anything in this range matches what we think should happen. This is typically denoted by CI for confidence interval. And we're going to kind of go through an entire example and all the parts that deal with confidence intervals and how to set them up today. Along with that, we have to have a level of how confident we want to be. And so there's 3 confidence levels that we are typically going to use. And they're 90%, 95, and 99% confidence. What this means then is 1 minus the alpha level. So the alpha level is the 1 minus the alpha level is the confidence interval. So if it's a 90% confidence interval, my alpha level is 0.1, because 1 minus 0.9 would be 0.1. 95%, 0.05, 99%, 0.01. Now these alpha ideas are useful, okay, to get the z-score that we're going to be using for each of these confidence intervals. This is also called the confidence coefficient, this degree of confidence. There's a couple ways you can look at it. Our focus is going to be on these 3 as we're looking at our lessons. Okay, so let's go back to our example. 70% of the 1,501 people have brown hair. The 95% confidence interval is from 0.677, less than p, less than 0.723. Now you can think of this as a range. So the low end is 0.677 and the high end is 0.723. Anything in that range is where we most likely think, oh, this is where things are at. We're confident, okay, that they're in these between these kind of 2 numbers. There's some other ways to write these pieces, and we'll look at some of that later on in this lesson. First thing, though, we need to understand about confidence intervals is how to interpret them and write them. So for the example that we're looking at, we are 95% confident that the interval from 0.677 to 0.723 actually does contain the true value of the population proportion, which in this case is the proportion of people with brown hair. So we're 95% confident that the actual proportion of people with brown hair is between those 2 numbers. Now, we can't guarantee that because maybe our data is a little bit off. We don't know, but we're fairly confident, 95% confidence, it's in between those 2. What this means is if you keep taking samples of that size over and over and over, and obviously there are different random samples, 95% of the intervals would actually have the proportion. What it does not mean, though, is that there's a 95% chance or probability it's between those 2. Because it's either in that interval or it's not in that interval, and we can't really tell you that. We also can't say that 95% of all of the proportions of the samples will be between those 2, because that information, those 2 numbers that we found, are only for that data set that we just collected. If you had a new data set, you'd have a new set of numbers, and the confidence interval will be slightly different. So you have to make sure that this is your conclusion. You're going to be asked to write some conclusions as you look at testing as we move through this unit. So you want to make sure that you're able to write some of those things out and practice them as we move forward into this lesson. This is what we mean by the confidence level of 95%. Now this is for the means, but the proportion questions are exactly the same. What this is saying is all of these lines here are the confidence intervals. Now we don't know what the actual proportion or the mean is, okay? But we know that if we're 95% confident, if we keep taking samples over and over, we should expect that 95%, okay, 19 of the 20 in this case, okay, will have that actual parameter involved. So notice here, though, that this one in red, this is my confidence interval, but my actual number was outside that confidence interval. That's okay. That happens sometimes. That's why we kind of, it's kind of like the, like the warning labels and the real small print, fine print at the end of something or on the back of a label. Okay, that's kind of what this is. We can tell you how confident we are, but hey, sometimes it's going to be off. Okay, and that's okay. That's what the 95% confidence level will do for us. Okay, now back to the z-score with alpha idea. Okay, so this chart's right from your textbook. What we need to find is the cutoff points, what are known as critical values that would separate what's unusual versus usual. We find that by doing the z of alpha over 2. Okay, these are those critical value locations, kind of like what we did before. It was this z subscript of a number. Remember, that was always area to the right. And so this is where it actually comes into play. The reason we have to divide by 2 is confidence intervals always are from the center and go out in both directions. So because of that, we have little areas on the left and right side that are left over, and they're symmetrically the same. So I take the alpha level, the leftovers, divide by 2, and that tells me what's left over in those areas to the left and right. Okay, we should only have to go through this idea one time. Let's find the critical values for the different confidence intervals. So we're looking for the critical value, z alpha over 2, okay, corresponding to 90% confidence. If something is 90% confidence, that means the alpha level is 0.1 or 10%. I divide that by 2 to split it up perfectly in both ways. So 0.05 is area to the right. That means 0.95 is area to the left. I find the z-score in the table that corresponds to 0.9500, and that's 1.645. That should kind of make sense. If you think about it, we've dealt with this 5% idea in the past, and with the highest and lowest 5%. So it's not surprising that that number, which is one of the starred ones on your chart, is used again. For 95%, alpha would be 0.05. So alpha divided by 2 would be 0.025. That's area to the right. Area to the left is 0.975. Find 0.975 in your table, and you get 1.96. For 99%, it's 0.01, and then divide by 2, which is 0.005. That's area to the right is 0.005, area to the left is 0.95, and that gives me a z-score of 2.575. The nice thing is, those are the three you have to know really well. It's possible you might have a 98% confidence interval, which means alpha is 0.02, divided by 2 would be 0.01. It's possible you could have that on your homework. That would be the only other one I think that you might see. My focus is going to be on these three. The nice thing is, in your chart, if you look on the positive side, there should be a spot in the bottom right corner that says common critical values, and it says confidence level and critical value. And they're the three things we just found. Okay, so that's a reference. It should be right on your paper on the bottom corner, and that should help you whenever you're dealing things with confidence levels and confidence intervals. The other thing we need to look at is also called the margin of error. I can give you a point estimate of where I think it is, and then what the margin of error says is how far apart are you, which is basically a similar idea to like standard deviation. How far away from average are you? It's denoted by the capital letter E. It shows the maximum kind of usual or likely distance that you can be from the sample proportion. Okay, so that's what we're trying to find. There's a formula for it, and we'll use that to be able to find then the confidence interval. So here's the formula. The maximum error of the estimate, which is called the margin of error, is found by this formula. Notice that z alpha over 2, that's just one of those three z-score values that we just located, so like 1.645, 1.96, 2.575, times the square root of p hat, q hat, which is sample proportion, and then 1 minus that, and then divide by n. That's all in the square root. This works for any binomial distribution. So you have to remember to check if n times p is greater than 5, n times q is greater than 5, like what we did in our last chapters. In most cases, that's going to be the case as long as your data set's big enough. It shouldn't be an issue. But then you just plug all of that in, and that gives us the margin of error. Okay, now let's talk about the confidence intervals themselves. To find the interval, we take whatever my point estimate is, or my sample proportion, minus the margin of error, that's the low end, and the sample proportion plus the margin of error, the point estimate plus the margin of error, and that gives me the high end. You can write it in 3 ways. I'll be honest, I tend to write in the third way, just because it shows the two numbers kind of in an interval notation setup. You'll see some in the second setup on some of your homework questions where it's just the point estimate plus or minus the margin of error. And you'll also see this first one, which is what we started with earlier, which was like the 0.677 less than p less than 0.723. All 3 of those really mean the same thing, and they can all be useful as you're looking at these scenarios. All right, so let's go all the way back to what we started with. I gave you all of this information before, but it's very easy to find. 70%, that's p hat. 0.70 is p hat, which means q hat is 0.30. N is 1501 because that's the number of people. Find the 95% confidence interval. I've told you earlier it was this. Now let's find it. So the first thing I need to find is the z-score that I'm going to use. Since it's 95% confident, I'm going to go to 0.95 on my confidence interval, and it's 1.96, always. Okay, for 95% confidence interval for probability or proportion questions like this. Times the square root of p hat times q hat divided by the square root of n, which is the 1501. When I find that answer, that's 0.023. 3 ways you could write that. One way, the confidence interval would be p hat, which is 0.7, plus or minus 0.023. That's one way. Second way would be to actually add and subtract those. So 0.7 minus this 0.023 is 0.677. 0.7 plus the 0.023 would be 0.723. I put that in parentheses, comma in between. That's also a way to write the confidence interval. The third way is you write the first number less than p, not p hat, p, because we're trying to see where the population proportion is, not the sample, and then less than 7.23. All 3 of those would be acceptable ways to write. To be honest, I think this parenthesis one with the interval notation is probably the easiest to write, especially digitally. But your homework may use any of the 3 at different times. Remember, 0.7 is the point estimate, and 0.023 is the margin of error. Based on these results, can we confidently say that a majority of people have brown hair? And the answer is yes. If it's a majority, that means that we want at least 50%, okay, higher than 50% of people. So if we look at our confidence interval, this entire confidence interval is above 50%. And as long as all of it's above 50%, we're fairly confident, 95% confidence, that it's in that majority. Let's say this number was 0.47, though. If any of the confidence interval, if your number that you're trying to figure out if it's important or not is in that interval, then you can't say anything. We don't know. You can't say, well, most of the interval is above, so I should just assume it's above. We can't really say that. It either is in that range or it's not in that range. And so in this case, it's okay because 0.5 is outside of that range and everything else is higher. A brief statement to describe this situation. You want to make sure you're practicing some of these. Your homework doesn't do a great job of this because it's a lot of multiple choice situations, but you are going to have to be able to write some of those things out. So we are 95% confident that the true proportion of people with brown hair, the true proportion, is between 0.677 and 0.723. Really all you're doing is taking the information that you've had right here and then applying it to this situation. Okay, so we are 95% confident that the true proportion of should be the same every time. And then it's of what? Well, people with brown hair for this question, and then is between those 2 numbers. You want to be able to write those pieces out and be able to explain them as we're moving forward. Okay, that was a lot of information, a lot of setup. We're going to kind of recap a few of those things on our next lesson, do another example. We're also going to figure out how to deal with some sample size questions as well and to figure out how many people we need to kind of collect data from in order to have an accurate conclusion. Please make sure you understand how to find the margin of error, how to deal with a point estimate, and how to write your confidence interval and interpret them. Have a good day, everyone.